All right, let's talk about the next huge leap in AI. We're moving way beyond AI that just talks. We're talking about AI that acts. Welcome to the world of Agentic AI.
You know, for the longest time, we thought of AI as this super smart calculator, right? Or maybe a clever chatbot. But what's happening right now is a total game changer. We're shifting from these passive tools to systems that are actually autonomous, systems that can chase their own goals. And believe me, this isn't just some minor software update. It's a whole new ballgame.
So let's really get into it. First things first, we've got to make sure we're all on the same page. What does it actually mean for an AI to have agency?
Okay, this is a really important distinction to get right. Think about it like this. You've got an AI agent, which is like a single, super skilled worker. It can tackle a whole complex task by itself, maybe write an entire project proposal from scratch. But then you have agentic AI, and that's more like the whole team, or even the manager of the team. It's the system that coordinates a bunch of these specialist agents, say a researcher, a writer, and an editor, to get the job done together. So one's the individual, the other's the whole collaborative operation.
But here's where things get messy. This field is just moving at lightning speed, right? And because of that, there's a ton of confusion. The way we're used to thinking about AI, well, our mental models just haven't caught up to what the tech can actually do now.
And the paper we're looking at has a great term for this: conceptual retrofitting. Seriously, imagine trying to fix a Tesla with a manual for a horse and buggy. It sounds ridiculous, but that's pretty much what's happening. We're grabbing old concepts from the early, rule-based days of AI and trying to slap them onto these new sophisticated language model agents. It just doesn't work, and it's giving us a completely wrong picture of what's going on under the hood.
And look, you don't have to take my word for it. The paper itself is really blunt about this. It points to this massive confusion, this conflating of modern AI with the old school models. And why does this matter? Well, it's not just some academic squabble. This confusion makes it way harder for us to build, test, and frankly govern these incredibly powerful new systems.
And a quick look at the history of AI makes it so clear why we're all so mixed up. See, that first era, symbolic AI back in the 50s, was all about hard-coded logic and rules. But the agentic AI we're seeing today, it comes from a totally different branch of the family tree. It's a direct descendant of the generative AI era. They're built on completely different principles from the ground up.
So the big question is, how do we fix this mess? How do we get some clarity? Well, the paper offers up a really elegant solution. It basically gives us a new map to navigate this world. And the key insight is this: we need to stop thinking of agentic AI as one single thing. We need to see it as two.
And this is the core of their solution, a dual paradigm framework. Just think of it as splitting agentic AI into two distinct families, two lineages, if you will. These two families grew up completely separately, and they have fundamentally different ways of thinking, of seeing the world, and of getting things done.
And this table here just lays it all out beautifully. On one side, you have the old school, the symbolic paradigm. It runs on strict algorithms, makes decisions based on rules. The big plus? It's super verifiable. You can actually look at its logic and see exactly why it did what it did. But then you've got the neural paradigm. It works through conversation, and its decisions are generative, probabilistic. It's a bit more of a guessing game. It's way more flexible for sure, but trying to trace its reasoning? Good luck. It's much more of a black box.
Okay, let's zoom in on that first family, the symbolic lineage. The perfect metaphor here is a master architect. This AI follows a perfect, detailed blueprint. Every single step is planned out. It's predictable, it's reliable, but here's the catch. If it runs into something that's not in the blueprint, the whole thing can just shatter. It's incredibly powerful, but also incredibly brittle.
And its whole process is this very neat, very logical loop. First, it perceives the environment. Then, it plans its next move using its internal rulebook. Then, it acts on that deterministic plan. And finally, it reflects and updates its understanding of the world. It's all very methodical, very step-by-step.
Now let's talk about the other family, the neural lineage. And if the first one was an architect, this one is a total improvisational jazz musician. There's no rigid sheet music, no blueprint. It just listens, it adapts, and it comes up with something new in the moment. The upside is it's unbelievably flexible. The downside? Well, sometimes you have no idea what note it's going to hit next.
So what does it look like when this jazz musician plays? Well, forget that neat, rigid loop we just saw. Neural agents work in these much more fluid, dynamic ways. Maybe they'll spin up a conversation between multiple AIs to bounce ideas off each other, or they'll pull in outside information to ground themselves in the real world. The whole approach is just fundamentally more adaptive and, well, conversational.
Okay, so at this point you might be thinking, architect, jazz musician, this is all just theory, right? No way. This distinction has massive real-world consequences, because deciding whether you need the architect or the jazz musician for a particular job is an absolutely critical strategic call.
And you can see this playing out right here. When you look at high-stakes fields where safety is everything, like healthcare, you see the predictable symbolic paradigm is king. You just have to have those rules that audit trail. But then you pivot to a world that's constantly changing, drowning in data, like finance, and that's where the adaptive neural paradigm really shines.
It all comes down to using the right tool for the right job. Simple as that. In a hospital, you absolutely want the architect, that rule-based system that guarantees patient safety. But if you're trying to make sense of the chaotic, ever-shifting financial markets, you bring in the jazz musician. You want that multi-agent system that can improvise and spot patterns that no human ever could. Which brings us to the big finale, the really critical question. We've got these two incredibly powerful but totally different families of AI. So what's next? Where do we go from here?
And the answer is not that one of them is going to win. It's not a competition. The real future, the most exciting frontier in all of this, is figuring out how to bring them together. It's all about intentional, smart integration.
So what does that actually look like? Well, this is the roadmap. It means we need to build hybrid systems. Systems that use the neural networks for the stuff they're amazing at, like perception and creativity. But then we bolt on the symbolic engines to handle what they're good at, like rock-solid logic and safety checks. That's how we get the best of both worlds. That's how we build systems that are both incredibly adaptable and totally reliable.
And a paper just wraps this up so well. The ultimate goal here is to get the best of both worlds. We want to create AI that has all the creative, adaptive genius of a jazz musician, but is also guided by the precision and reliability of a master architect.
And so, that leaves us with the ultimate challenge, doesn't it? The goal isn't just to build smarter AI anymore. The goal is to build trustworthy AI. And the biggest puzzle for all of us to solve in the next decade is exactly this. How do we fuse these two powerful lineages to create systems that aren't just intelligent, but that we can actually truly depend on?